Welcome back, guys. We're here with part 2 of the Drivetrain final project for the Stellar Robotics 2018 CAD class. We ended off with this assembly, and I forgot to save it, so I'm going to save it now. So this is SR18 CCD for CAD class Drivetrain. It's going to be ASSY for Assembly 001. All right. Okay, so let me think here. We're actually going to go ahead and put the mounting holes in this plate here, and then we're going to do a save as and copy it for the inner drive rail, and then we're going to modify it slightly, and it's going to be very slightly modified. The biggest difference between these two plates is going to be that the inner plate has to mount the gearbox and the outer plate does not. We are going to put lightning holes in here. Really, that's the big primary goal with this project, is to be able to do the lightning patterns and stuff for this drivetrain. However, we have to get the whole thing modeled first. So let's go back to, I'm going to drag these. You can click and drag these tabs and reorder them. We don't need I'm going to color the bearing block because the bearing block is done. Document appearances. Of course. Now I lost it. Do I have Stellar Yellow somewhere? Let me think here. Let's open this. I need to... You guys won't have this color on your computer, but I want it. Favorites. Now do I have access to it? Of course not. Alright, I'm not going to mess with it. I'm just going to show you guys how to recreate it. So, this was copied. Oops, edit. Edit. 255, 188, 11. Alright, so closing out of this. Alright, so if we go, let's set it to a glossy material. I usually use, blue. Usually use this, and then I change the color. So click the little pinwheel right in between the material and the appearance drop downs. Right click on blue wall paint, this one in here, hit duplicate. We're going to rename it to Stellar Yellow. Then find the one, it'll jump around and go to alphabetical order. So right click on that, Stellar Yellow, and click edit. This is a slightly different glossy than the other one was. But we can go into here, go to define custom colors, change to 255, 188, 11. Click OK. Click OK. And then right click on that and just add it to favorites. I'm just going to replace it, and then I'm going to right click on the blue and add that to favorites too. Alright, so now I can go to favorites, Stellar Yellow, and the Stellar Yellow still shows up blue because reasons. Alright, that was a whole lot of work just to get one little bearing block to be yellow, but it's yellow now. So save it, close it, we're done with it. If you guys remember from the drum roller project, I only color stuff when they're actually completely done. So basically what we're going to do is we're going to put a row of holes in the drive rail, starting here, centered left to right, all the way down. Now we base everything on FRC robots off of a half-inch hole pattern or a 1-inch hole pattern, depending on who you are, but you know, half-inch hole pattern is just twice as many holes as a 1-inch hole pattern, so they're completely compatible. So basically what we're going to do is we're going to have a hole. This is an inch wide, remember, so we're going to have a row of holes that's in the middle, half-inch in from this side and a half-inch in from this side, and they're going to be a half-inch from the end. However, they're not going to be a half-inch in from the end of this part. They're going to be a half-inch in from the drivetrain overall. So we've got to take off a 1/16 here to make sure it's a half-inch from the outside of the drivetrain to the first hole. So That just keeps everything lined up on half-inch centers, makes everything really nice, really easy to bolt superstructures to this and make modifications halfway through the season, which you will do. All right, so let's create a sketch here. We're just going to create one center point. There's going to be holes in the top flange and the bottom flange, so we'll make the holes go all the way through, and then we'll use a pattern feature to create the row. So let's pick the dimension tool. Now we've got our bend on this side, so we know this is our back face. That's what we're going to dimension from. So we're going to dimension from here to the center point. That's going to be 0.5. And then from this end flange to this will be 0.5, and then we've got to take off 0.0625, which is a 16th, which is the material thickness of our end channel. All right, so click OK. We'll finish the sketch. Click the hole feature. We're just going to do a simple hole, and then we're going to change the diameter to be 0.196, which is the hole size we use for rivets. We're going to make sure through all is checked so it goes through the bottom flange as well. All right, so now it's centered from back here to the front edge. You know, it's kind of close to the radius, but that never causes any issues. So now we're going to pattern this down the length of the part. So we're going to click rectangular right here on the sheet metal tab. We're going to click on the hole. You want to see these red dotted lines around the hole feature. So we'll click, and now we've got to pick a direction for them to pattern in. So we click this arrow by direction 1. We basically just need to pick an edge that runs in that direction. So it can be this edge, it could be that edge, it could be this edge. It just needs to run horizontally in the direction we want. So we're going to pick that edge. And the arrows are facing the wrong direction, so to flip that direction around, we'll click these little like curvy black and red arrows here. This whole center to center is going to be 0.5, and then we've got to figure out how many we need. It's like 60 something if I remember correctly. If you're doing a large number of holes, it'll pop this up. It's really ignoring dialog box, but it does it anyways. 62. Don't care. Just click OK. Okay, so if I do 63, we have a hole that's off the edge, which is not what we want. If we do 62, it's perfect. Okay, so click OK. Now if we measure, I'm going to press the M key to bring up the measure tool. If we measure from the center of this hole to the end, it's 0.438. And if we measure from this end to the center, it's 0.438. So we know it's the same left to right. All right, so that's good. Now we're going to do the same thing on the end. Once again, we're going to carry the hole through all, so it'll go through this flange down here at the other end too. All right, so create a sketch. Now, it is very, very important that you model this the same way that I am. You need to start with the hole at the top. You can't start at the bottom, you got to start at the top. So be looking at your view cube. You see the top is here. We got it. This is the top. I'll explain why that's important here in a bit. Okay, so place the point, and basically at this point we do the same thing we did before, except we are actually going to be a ½ inch from the top and a ½ inch from the side, because we don't need to take off a 16th, because the end channel that's sitting on top of this is specifically designed to go over top of it, so it's not cutting into our ½ inch hole spacing or anything. So, oops. 0.5, 0.5. Okay, and you don't actually have to exit. You don't actually have to finish the sketch to start working on a feature. So I can just press the H key, and I can just start doing a hole right now. Okay, so it's already through all. It's already 196. It's already a simple hole. So we can just click OK. All our options are still the same. We're going to pattern this down. So pick the hole. Click the arrow for direction, pick that direction. The arrow is facing the right direction. If it's not, you can flip it. The whole spacing will be ½ inch. It'll be 6 holes. Okay, and then if we press the M key to bring up the measure tool, measure from the bottom flange to there, it's a ½ inch. And it's also a ½ inch there, so it's centered top to bottom. Okay, so that's great. Those are all the mounting holes. Now, we are going to be lightening this. There are going to be lightning patterns in here later, but we're not going to do that right now. We're going to go ahead and round all these corners. So we're going to go to corner round. 1/4 inch is fine. Typically, I do, when we're filleting parts, like small parts like the bearing block, I usually go for 1/8 inch, but for larger sheet metal parts, I typically go for 1/4 just because it looks nice. Alrighty, so that's pretty much done. We're not going to color it though because we still have to do lightning. So I'm going to give this a save. We're going to go back to our assembly. We're going to add holes to this here in a second. Alright, so basically what we're going to have to do is this hole, and this hole, we're going to need holes here. Now, we're going to kind of do the same thing that we did here. We don't need all these holes. We don't need all of them. But we use these holes for mounting superstructure. We use these holes for mounting bumpers. We use these holes. So we want rows of holes all the way down these front and back channels as well. So we're going to take these 3 holes and we're just going to pattern them a 1/2 inch apart all the way down. It's a whole lot of holes, but it gives us a lot of mounting spots. So, and then we'll have to we're not going to do that on the front though, because you don't typically mount stuff to the front. You typically mount stuff to the top, which is why we want holes on the top. But you're not going to mount stuff to the front, so we're not going to put all those holes plus, 6 holes down the width of it, pattern all the way across. It's a whole lot of holes, and that's going to take a really long time to laser cut. Whereas a row of 3, top and bottom, that's half as many holes. Sometimes we just do the 2 outer ones and we don't do this middle one, and then we just do like one. We just put it in place for the drive rails, but I'm not gonna mess with that this time. So let's bring up the measure tool with the M key, measure from the outside to the first hole, which should be a 1/2 inch, and it is. Let's measure from the end of this flange to that hole there. That's also a 1/2 inch, and we know these are a 1/2 inch apart. We know there are 3 holes. So let's open this. It's already open, but that's okay. Let's create a sketch on the top face. Now here's what we're going to do. We're going to turn on construction geometry. We're going to create a line. Now we're going to dimension this line to be 1 inch long. We know we want 3 holes, and we know we want them a 1/2 inch apart. And so if we create this line, then we attach points to the end points and the middle. We know the middle is going to be half the length of the line, and the line is 1 inch long. So we know these 3 holes are 1/2 inch apart. So this is just a really quick way to doing it without having to dimension each point individually or place 2 dimensions, one between these 2 and one between these 2. So next, let's dimension the line 1/2 inch from the edge of the part, and this end point from the back of the part 1/2 inch. Alright, finish the sketch. Create a hole feature. I guess I didn't really need to finish the sketch. Okay, remembers our hole settings, so it's simple hole through all, 0.196 diameter, and it goes through both legs, which is fine. Next we're going to go to rectangular. We're going to pattern this same way we did before. Pick the hole feature. Notice it picks all of them just with 1 click, which is what you'd expect. Alright, so pick direction 1. Pick our direction. That's the wrong direction, so click the arrows to flip it to the other side. We're going to do 1/2 inch spacing, and I don't know, what is this, 40? Not even close. 50? That's fine. Looks like 50. Yeah, if we add another one, it'll be right on the edge. Okay, so click OK. Yeah, normally I would take this middle row of holes. I wouldn't put those in, but for what we're doing here, this is easier to model, and I think, actually, if I look, I think that might be how we did it last year. No, we didn't. So this is how we usually do it. We just add this extra hole in where the actual drive rails connect, but we're not going to do that for this model just because to save time. Alright, so next what we're going to do is we have to add holes for these. Now like I said, we're just going to do a row here, then we've got the next drive rail that's going to be in here somewhere. We're going to add a row for those, and then the same thing on the other side. So let's create a sketch on the back of this part here. Now we know we need a row of holes here, a row of holes here, a row of holes here, and a row of holes here. So what we're going to do is we're going to model 4 holes across the top, and then we'll pattern them down. So, but we're going to do this with some lines just to make it easier on ourselves. So we're going to turn on construction geometry, pick a line. We're going to create 1 line, so that's 1 line. Then we're going to create another line, make sure it's horizontal. Create another line, and then we're going to create a last line. So 3 lines. So next we're going to create points. We're going to create points at the end points of the line. Make sure you don't pick a midpoint somewhere. You don't want a midpoint. So there should be 4 points, 3 lines. Next, we want this to be half an inch plus the material thickness, because we know it's 3.5 on the inside. So it's going to be half plus a 16th. Then we know we want the end ones half inch from the inside or from the ends. So let's dimension both ends to be half an inch. Now we're going to have to move these holes. I don't exactly know where the mid drive rails are. They're usually somewhere around 4 inches. So that's what we're going to dimension these line segments to be, around 4 inches on center. They need to be a half-inch increment because that just helps line everything up with holes, and it makes it easier to design, like I've been mentioning this whole time, superstructures and such. So let's finish the sketch. Let's do the hole feature. Keeps our settings 196. That's great. Let's pick the rectangular pattern. Pick the hole. Pick the direction. That's the correct direction. Half inch and 6 holes. Click OK. Next we're going to radius these corners just like we did on the other part. Click OK. Alright, so let's give that a save. We're going to close this part for now because it's going to be a while before we edit it. We're going to have to add a few things to it, but for now we're fine. Okay, so next we've got all the mounting holes. You can see the mounting holes line up here. We would rivet this together. We need to add in an inner drive rail, and then we need to mirror it on the other side. Now currently this part is symmetrical front to back, and in a lot of cases that's what you would have. However, so we could design this part specifically so that it was reversible, so there wasn't a mirror image on the other side. However, we can't guarantee that that would be the case if we were designing a robot for the season, so we typically want to give ourselves the design freedom, and we create a mirrored copy of this part for the other sides. So we'll get a little more into that later, and that'll make a little more sense. But that's the reason why we can't just place a second one of these over here now. We gotta wait. Okay, so what we're gonna do is we're gonna do a save as on this. We're just gonna save a copy of it. So we're gonna go to File, Save As. This will save an additional version. So we gotta pick the next number. So it'll be 4. So part 4 will be the inner drive rail, and 1 will be the outer drive rail. Save that. Okay, so what do we need to do with this? Well, basically, we have to have a belly pan in the middle. Now, the belly pan does not go to the outside. The belly pan just connects to the inner drive rail. The 2 inner drive rails, the belly pan will be between those 2. So what we need to be able to do is we need to be able to slide the belly pan on top of this flange and under the drive rail. Essentially, if this were the inner drive rail, we need to get the belly pan in between this flange and this bottom flange of the drive rail. So what does that mean? We've got to leave a 1/16 of an inch gap in here, except for the inner drive rail, of course, to get the belly pan in there, because the belly pan will be a 1/16 of an inch thick. So basically we've got to make this a 1/16 of an inch shorter. We've got to pull the bottom flange up a 1/16 of an inch. Now, if you remember what I did before, let's go to this is our copy. So this is the inner drive rail. This is part 4. So we're going to go to face 1. We're going to edit our first sketch here. You remember when I went back in and I added this because this was 5/16 and I added a 1/16 to it. That's why I did that, because we need the bearing blocks on the inner drive rail with this bottom flange raised up. We need them to clear the bend radius. Then everything else, the outer wheels are higher up, so the bearing blocks don't come anywhere near the bend, and the outer drive rail is a 1/16 of an inch. This flange is a 1/16 inch lower than the inner drive rail, so also we're not coming anywhere close to interfering. So this is the inner drive rail model. Like I said before, you've got to make sure that you make a copy of it because you don't want to edit your outer drive rail. So we can make this back to what it was, and then we can edit this and take a 1/16 inch off the height. Now, because the wheels are dimensioned to the bottom, and then we took a 1/16 inch off the top, so that it ends up acting, we took a 1/16 inch off this dimension as well, so it ends up acting like we took a 1/16 inch off the bottom. So everything's good here. Finish the sketch. You can see our holes got closer to the bottom and our part got shorter overall. Now here is where the criticalness of the way we modeled this comes in. So if I now measure from here to here, that is a 1/2 inch. And if I measure from here to here, it's 7/16. It's a 1/16 inch less. That's because we took a 1/16 inch off the bottom, which is what you'd expect. But these holes will still line up with the holes here. So let's give this a save. This is also the reason why we didn't do a save as until after we added all the holes, because the holes are modeled the same way. Same thing with the bearing block holes. But the lightning patterns will be different because we're going to have motor mounting holes in here somewhere for our gearboxes and whatnot. So the point at which we did the save as, this is the point at which those two parts diverge. So you could remodel it from scratch, but there's no reason to spend 30 minutes doing that or whatever, however long it would take you. So let's place our inner drive rail in here. Part 4. Drop that down. The flanges are going the same way as the outer one. So we're going to constrain this end face here to there. Apply that. Remember the top to the inside. And then we're actually going to... I got lucky. I got the holes lined up. You might have to exit out of this and drag this part until the holes line up, but we can see them here. So if I go to constrain, I can just constrain one of these holes. Got to click this undirected one and then click OK. All right, so now I don't know if this is enough space in here. We may have to move this out a 1/2 inch or something. It looks kind of narrow, but I could be wrong. The big thing here, we look at this at the right angle, which that's not really the right angle, there's a gap between here and here. So if I measure, there's a 1/16 of an inch gap, which is great. So that's for our belly pan. We're not going to model the belly pan just yet. We'll model the belly pan later. We're going to go ahead and mirror these on the other side, and then we're going to do some more modeling for our bearing blocks to get the spacers and whatnot in there, and then we'll be getting pretty close to having the frame done. This project's going to involve like a lot of assembling to get this done. We'll see where we're at on the video lengths and just kind of play it by ear in terms of how much detail we model this in. I might not do the fasteners in this model just because A, there will be a lot of them, and B, I think you guys know how to do that at this point, so there's not really any reason for me to show you again and again and again. Alright, so basically we need a mirrored copy of this. So Inventor has a feature for that automatically. Essentially what it does is it creates a copy of the part, but the copy that you create is linked to the original part, so whenever you change the original part, it'll update the other one. So that's perfect for us. That means we can edit this part, and then we can come in here and we can update it, and the other part will change, and it'll still remain a mirror image of this part. That's perfect. So let's click this part. Let's click mirror. You have to pick a mirror plane. So you click on the mirror plane button, and we'll just mirror with this interface. So you can see it creates kind of like a highlight of what it's going to do. It's going to just reflect it around that face. So next you can click next. This here is the part that it's going to mirror. This here is the part that it's going to create. We don't want it with this suffix. We want to call this right hand because it'll be the right hand inside drive rail. So it'll be 04 and 04 right hand. Ideally, our original would be called 04_LH for left hand, but I didn't think far enough ahead to do that, and I almost never do. But we just name this right hand so we know which one it is. If it were to be the left hand part, I would rename this so that the mirrored one was left hand. You want to name it, if it's left hand or right hand, you want to name it the correct thing. So that's right hand, so we'll click OK, and it will create this part. If if I were to mirror a part that was grounded, the new mirrored part would also be grounded. You would have to right-click on it and uncheck grounded. But in this case, this part wasn't, or this part that we mirrored wasn't grounded, so the copy wasn't grounded either. All right, so let's constrain this in place. So we'll constrain it the same way. The end to the inside, enter. The top to the underside of the end channel, enter. Then we're going to constrain top hole to, this is the second row of holes, which is for the inside drive rail. Undirected, click OK. All right, so next we're going to do that for the outside drive rail as well. So we'll select that. We'll click mirror. We'll select our mirror plane. We'll click next. We'll get rid of the MIR and replace it with RH. Click OK. So now we can move the copy over here. And this is actually, once you save this, which I haven't actually saved it yet, it creates this file, and then there's actually a file in the folder, which I'll show you shortly. All right, let's constrain this guy as well. So let's constrain end to the inside, enter, top to the underside, enter, and then this flange here needs to be flush with the outside. Okay? So now this can't move, that can't move, that can't move, that can't move. Alrighty. Let's give that a save. Click OK. Alright, we're going to do one more thing here. So we're gonna go through and we're gonna put all the bearing blocks in, and then we're gonna end this video. We'll deal with the belly pan and the gearboxes and the shafts and the wheels and all that stuff in a later video. Okay, so what we need to do, we're done with this for now, I think. We have our bearing block model. I'm actually gonna just open that. However, we need that spacer plate. We need that spacer plate, that 16th inch spacer plate that separates the flange, that gets us away from the flange. So let's actually make a copy. Actually, no. No, I'm going to make a copy of this part because this part is so similar. We can just make it thinner, and we can make this middle hole bigger, and we'll have our spacer. So I'm going to do a file, save as. I'm going to give it the next number in the series, which will be 5. Next, I'm going to edit. I'm going to right-click on Extrusion 1, click Edit Feature, change the thickness to be a 16th. Then I'm going to edit Sketch 1. I'm going to make this 1.25, and then I'm going to add 10 thousandths to it. You don't want this to be tight on the flange, so it ends up being 1.26. Is fine. All right. So it's a really lightweight part. Like I said, it's just a spacer, but this really does its job very well. Okay, so we can close this. We'll place in the assembly. So those spacers aren't on the inside drive rails. Those spacers are just on the outside drive rails. In addition, the inside drive rail center hole does not actually get a bearing block because the gearbox will provide a mounting structure for it. Actually, I take that back. I think we are going to put a bearing block there. Typically on a shifting gearbox, you can't put a bearing block here for various reasons, but we're not going to do a shifting gearbox, so we're actually going to go ahead and put a bearing block there. But like I said, the inside bearing blocks don't get that spacer because the flange is facing on the outside of the bearing block, whereas these outside bearing blocks on the outer drive rail, the flange is facing in, so you need that spacer. So let's go ahead and let's create some sub-assemblies here to make this easier on us. So let's we're going to create new assembly. We're gonna kind of assemble the bearing blocks all as one sub-assembly. So let's start with our inside one. So let's place that grounded at origin. Now we need a bearing to go in here. So we're going to go to VexPro's website, inside bearing blocks, think about that. Yeah, all of these are going to be half-inch round bearings. Yeah, that's what we usually do. Okay, I just had to remember there. Okay, so let's go back to Vex's website, go up to hardware, go to bearings, and scroll down to CAD files, and we're looking for half-inch ID radio flanged. Half-inch hex, half-inch ID, 1/8 OD flanged. Download that bad boy. This is the same bearing we used in that one spot on the Gearbox project earlier in the class. All right, so let's right-click that, show that in folder. And actually, I have this pulley in here, so we're going to just select both of these, cut them both out. Go to our Google Drive, go to the CAD file, CAD folder, go to the fall, Drivetrain, just paste these in there. Close that. All right, go back to Inventor. We're just going to import the bearing for now. So click Files of Type, scroll down to All Files, find the bearing, click Open. Come on. All right. Next, click OK. Delete this little extra sketch that it creates. Create a work axis in the middle. Set the material to steel. Just plain steel. I don't know what alloy it is. Then we're going to go to Inventor Material Library. We're going to go down to S. We're going to do semi-polished. All right, so give that a save. So next, in our little assembly we're creating here, we're just going to put a bearing in this, and then we're done. If we end up putting fasteners in this, we'll end up putting the screws in here too. But for now, we're not going to mess with the screws. So let's place the bearing. We're going to rotate it once by the x-axis so that the flange is on this side. So next we're going to constrain. We're going to use an insert. We're going to grab right here under the head and the rim of the hole. Click OK. All right, so this is a subassembly, just really simple with 2 parts. If we end up adding fasteners, like I said, it'll get more complicated, but this will save us a lot of mouse clicks. To be honest, usually I don't create this subassembly because it ends up causing more problems than it saves. But if you're careful, this can save you time. So give that a save. We will call this assembly 2. All right, now we need to create another one of these that's quite a bit different. So let's create a new assembly. Go to the home view. Let's place a bearing block, place grounded at the origin. Next, we're going to put the bearing in, but we're going to insert the bearing the other direction. So we're going to rotate 3 times by the x-axis. Go to Constrain, Insert, Insert on the back face. Then we're going to bring that spacer plate in here. Oops. So place the spacer plate, and basically the spacer plate goes on the back. So we're just going to go to Constrain. We're just going to constrain the 2 faces together. Then we're just going to flush. Oops. Flush the tops together and the sides together. So now you can see this is you can see the flange of the bearing is now kind of sunk down under this spacer plate because the spacer plate's a 1/16 and the flange of the bearing is a 1/16 of an inch thick. So now we can just flat mount this against the inside of the drivetrain. So let's give that a save. We'll call this assembly 3. We can close both of these. All right, let's start with the insides. We're going to do 1, 2, 3, and then 3 on the other side. So it's the first one. Assembly 2 is the inside. So we're just going to place 1, 2, 3. Then we're going to rotate 180 degrees and place 2, 3 for the other drive rail. We'll go ahead and place the outer ones. So it's going to be 1, 2, 3, and then rotate 180 degrees, and then 1, 2, 3. All right, so now what I'm going to do, yeah, so I'm going to go through, I'm going to constrain all the back faces to the face that they're supposed to attach to, and then I'll go and line the holes up. I'd like to use an insert, but it's going to be too much of a pain in the butt to use an insert, so I'm not going to do it. Actually, I think I can make it happen. No, I'm not going to do that. Okay. Constrain. Alright, mate, back of the plate to the inside of the drive rail, and then just bang out all three of these. When you've got all these parts floating around, it's important to remember which parts are supposed to go where. Okay, next these, it'll be this back face on the inside of the drive rail once again. And once I finish with these, I'll move to the outer drive rail ones. So inside face. So you'll notice the flange of the bearing is sticking out towards the in between the drive rails, which is exactly the way it's supposed to be. All right, so next it's going to be basically the spacer plate up against the inside of the drive rail. Spacer plate, drive rail. Go through and just do all of these. Alright, so now we're going to line the holes, the center holes up using this work axis. And this is still a mate constraint, so line that up. And we're going to switch it to undirected and then apply. And then it'll remember that it's undirected from now on. So as long as I don't hit escape and exit out of the place constraint dialog, it'll remember that. So I'm just pressing enter after each one of these. So center line, the whole axis, center line, whole axis, center line, whole axis. Same with the outside. Okay, center line and the whole axis. Or I guess it's a work axis and then the whole axis. Okay, so now my only problem is that these can rotate. So what I'm going to just do, I'm going to press Control Z to undo that. I'm just going to go in and kind of line up the two holes using that same constraint. So I'm going to go to Constrain. I'm going to go to keep it on Mate. I'm going to pick these two, pick Undirected, and then I'm just going to go down the line. Press Enter. And it doesn't really matter. You just have to do one hole on each bearing block, and it doesn't matter which hole you do. You just got to make sure you line one hole up. I got to get an angle where I can see the inside ones. Okay. Alright, so then going down the outside on the opposite side of the drivetrain. Get kind of an angle going on this. Here we go. And this is lower. Alright, that's all of those. So now we have so this bearing can't come out to the can't move to the inside and can't come out once this is bolted in the way it's supposed to be. This bearing will be held in place by a flange on the shaft, which we'll model another time. This will make a little more sense once we get farther in the model. So we're done with this video. Next video we're going to model the gearbox and get that in there. We'll get shafts in there. Actually, yeah, we'll start with the gearbox, then we'll put the wheels in, then we'll figure out if this drive rail's in the right place, and then we'll model the shafts. And then the belly pan will be the last thing we do. So, thank you for watching. Tune in for the next one. See you then.